Today we're talking about Lewis dot structures. And this is one of the rare times in this class we get to write a name down from an American. So, there was an American chemist. And his name was G.N. Can you guys guess what his last name was?
Lewis.
Good job. G.N. Lewis, who created a system, and this is the good part about this, to quickly, so this is why you guys are going to like this, to quickly represent an atom's valence electrons. Now, valence electrons are something we have mentioned in this class before. Does anybody remember what a valence electron is? Yeah?
The electron in the outermost ring.
Good. You guys just spent 10 minutes figuring out the number of electrons in the outermost ring, which means what were all of these electrons? Valence electrons. You were determining valence electrons. Okay? So valence electrons are the electrons in the outermost energy level. Oh, I cannot spell outer to save my life. Yeah, I can, yeah. Is that better? Yeah, okay. So, G.N. Lewis figured out a system where we can look at valence electrons really quickly, and that system is called, so I'm going to put a star, it's called a Lewis dot structure. We also call these dot diagrams, so I'm going to put dash dot diagram. That's not something that I say very often, but I want you guys to know if you ever see the word dot diagram, we're just talking about a Lewis dot structure. So the way the Lewis dot structures work is you start with the symbol of the element. Where can you guys find element symbols? On the periodic table in the box. Good. And then you surround the symbol with dots. What do you guys think that those dots represent? Electrons. Good. So the dots represent what type of electrons? Valence electrons. Very good. Yes, and I'm sorry, I'm going too fast. Is that okay? Can you guys see the whole thing? Okay. So the thing that people always struggle with when they're drawing Lewis dot structures is they usually do a good job finding the symbol. They usually do a good job finding the valence electrons. But then when they go to put it together, they make the same mistake. When you make a Lewis dot structure, you have to imagine that your dots are always arranged in an imaginary box. around the symbol. And I'm going to show you what this means in a minute. So I'm going to give you guys a minute to catch up. Sorry, I was writing too fast. All right, I want to show you guys an example of a Lewis dot structure. So we're going to look at neon. So on your periodic table, guys, can you find neon? How many protons does neon have? 10. So if it's neutral, how many electrons does neon have? 10. Now here's my question. How many valence electrons does neon have? Where'd you guys find that? Yeah. This is what you guys did on this paper. Neon is right here. So you used your worksheet to find how many valence electrons neon has. What were you guys looking at when you found that out? What did you look at? So you looked at its what did you guys what worksheet did you guys use to find your answers on that page? The atom drawings. So to find valence electrons, what did you look at? The atom drawing, right. You looked at neon's atom drawing. If you guys are ever taking a quiz and you completely blank and you're like, oh my gosh, I don't know how many valence electrons this is, I don't know how to find it, just draw the atom. That is a really good way to find valence electrons. It's a really good way to check your answers. I am going to show you guys an easier way to find valence electrons. So you guys know how to use your atom drawings to do that because that's what you did on page 42. Now I want to show you guys an easier way. So I am going to come back to this. If you're not done writing, I will come back to this. Can you guys all look at your periodic tables for a second? Okay, so if you look at that first family in the periodic table, what is that family called? No, the first family. They're not the noble gases. The alkali metals. Do you guys see at the top of that family where it says 1IA, 1A? I want you guys to circle the 1. That 1 tells us something important. How many valence electrons do you guys think all of the alkali metals have? 1. That's what that number tells us. What's the second family called?
Alkaline earth.
Good, alkaline earth metals. And do you guys see that number 2 at the top? How many valence electrons do you think they have? 2. So the number at the top of the family tells you how many valence electrons every element in that family has. Now, the transition metals, so columns 3 through 12, those are weirdos. We're going to pretend like they don't exist for a while because they do not follow that rule. Okay? So we're going to actually skip and go over to the other side of the periodic table. What is this family right here called? The boron family. And then what number do you guys see at the top there? 13. If you circle the 3, not the whole 13, just circle the 3, how many valence electrons does that tell you these guys have? 3. What's this family called? The carbon family. How many valence electrons do they have? 4. The nitrogen family has? The oxygen family has? What is this family called? The halogens. How many valence electrons do they have? 7. What about the noble gases? 8. So the number at the top of the family tells you how many valence electrons you
I
have.
have a question.
Yeah.
Is it because the transition metals, since they're weird, is that why they have B's instead of A's?
Yes. So we separate them because they act differently. Okay? So now, I want you guys to find neon. Find neon. What family is it in? It's in the noble gases. So how many valence electrons does the periodic table tell us it has? 8. And you look at your notes. We wrote down 8.
How does helium have 2?
It's a really good question, and I'm going to answer that in a minute. So you can definitely always draw the atom to find valence electrons. You can also use the periodic table. Either way, you'll get the same answer. Okay? All right, so if we're going to draw neon's Lewis dot structure, it tells us right here that I have to start with the symbol. So what is this symbol for neon? Ne. And then to make sure that I put the electrons in the right place, I'm going to use dotted lines to make like an imaginary little box around neon. And how many valence electrons does neon have? 8. So how many dots do I need? 8. So the way that I usually do this is I usually go around in a circle and then just fill in as I need to. But there is a rule for Lewis dot structures. You cannot have more than 2 electrons per side. So I'm going to go through and I'm going to put 1 dot on each side. And that only gives me 4, so I'm going to go around again. But I cannot put more than 2 dots on each side. So if I remove my imaginary box, my Lewis dot structure for neon looks like this. My symbol for neon with 2 dots on the top, 2 dots on the side, 2 dots on the bottom, 2 dots on the left side. The reason you can't have more than 2 dots on each side is when we start talking about bonding, electrons, if they're going to share an electron, they'll only usually share 2. If they share 3, that's kind of an exception. So it's the best way to evenly disperse the electrons so that those negative charges aren't close together. It's a really good question. Any other questions? Yeah.
Wait, so why would, what's the point of this if you have it on the periodic table? What makes it different?
So this is a really quick way to be able to look both at the element and its electrons at the same time. The reason we do these is so when we start talking about bonding, I can really visualize the movement of those electrons because I'm looking at both the element and its electrons at the same time. So you're right, I can get this information from the periodic table. But when I start talking about bonding, having this is a helpful image for our brains. Another good question. Okay, I'm going to help you guys set up your homework. So this page will come back up, but I want you guys to flip over and look at this for a second. Oh, my foot is very asleep.
Oh, are you just drawing it?
Yeah. So on your notes, this is page 42. On your notes, you have a little periodic table. Does anybody know why we have a gap right here? Yeah, we took out the transition metals. So we're just looking at the first 3 or first 2 elements in a family, and we're not talking about the transition metals. So the first thing that I want to do is go through and number our columns. So what is the number that goes at the top of the alkali metals? A 1. On the alkaline earth metals? 2. On the boron family? 3. It's really a 13, but remember we circled the 3. And then I have 14, 15, 16, 17, and 18. I want to do 3 of these with you guys. So what element goes right here, the top of the first column? Hydrogen. So I'm going to write the symbol for hydrogen. What element goes right here at the top of 13?
Boron.
Boron. And its symbol is? B. And what element goes at the top of column 18? Helium. He. Okay, how many valence electrons does hydrogen have? 1. And if you guys forget, that's why you did all of this work. Remember, you know all of these valence electrons. So hydrogen has 1, which means how many dots do I need to put around hydrogen? 1. So that's it. There's the fluid dot structure. How many valence electrons does boron have? 3. So I'm going to put 3 dots around boron. Now I want to show you guys something. So I'm going to draw a little bit down here. If I would have drawn boron's Lewis dot structure like this, that's totally fine. I could have drawn it like this. I could have drawn it like this. All of these are correct. So how you orient the electrons doesn't matter as long as you follow the rules. What would be wrong with me putting this? Right, remember you can only have 2 on each side, so this one has too many. What would be wrong with me putting this? It's got to be on your imaginary box, right? So I have to have them hugging the symbol, and I can't have more than 2 per side. But besides that, all of these are perfectly correct. Now, what about helium? This one's tricky. Because if you look at the column that helium's in, how many valence electrons does that make it seem like it should have? 8. But if you guys go up, how many electrons does helium have?
2.
It only has 2. So how many valence electrons does it have? 2. So helium is the only exception to the family number rule. Helium doesn't have 8 valence electrons, so it can't have 8 valence electrons. It only has 2. Every other element in this column has 8, but how many dots do I need to put around helium? 2.
Question.
Yeah.
So, like, would it matter how you put it if you had 2? Like, could you put them both on the same side?
Yep, I could put them like this. Okay, I could put them on either sides. Okay, yes?
What about the elements with 18?
Good question. So even if they have 18 electrons, we're never going to draw something that has more than 8 valence electrons. Okay? So the Lewis dot structures only work for elements that have 8 valence electrons or fewer. It's a good question. So we're only going to talk about the first 18 electrons for that reason. Yes?
Would it be wrong if you put the same model? Like instead of putting
No, so this right here, that's totally fine.
okay.
Okay? You just can't have more than 2 per side.